Hello friends, this video on light, reflection and refraction part 14 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 13 before going ahead with part 14. So now in the entire lesson, instead of using the term optically denser and optically rarer, we will use the terms rarer and denser medium. Right? So now let us see what happens when a ray of light enters from a rarer medium to a denser medium. Now whenever a ray of light enters from a rarer medium to a denser medium, it always bends towards the normal. Now why does that happen? Let us look at it. Let us suppose this is medium 1 and this is medium 2. This is my rarer medium and this is my denser medium. This is the normal. And let us suppose this is my incident ray. So now it will bend, that we know, but how much will it bend and how will it bend? Now from Snell's law, what do we know? We know that sin I by sin R is equal to n to 1. That is refractive index of 2 with respect to 1. So now we are telling that 1 is rarer medium and 2 is denser medium. That means from the previous slide, we can say that this implies n to 1 is greater than 1. That means refractive index of 2 is greater than the refractive index of 1. Now if n to 1 is greater than 1, then we can say that sin I by sin R, which is equal to n to 1, is also greater than 1. That means sin I is greater than sin R. So from this we can say that I is greater than R. So this angle of incidence will be greater than the angle of refraction. That means this angle should be smaller. So when will this angle be smaller? Let us suppose if there is no bending, then it should go like this. In that case, angle I and angle R will be same. But whenever bending is there, if it moves towards the normal, then angle of refraction will be less. Right? So that means in this case, the refracted ray will bend towards the normal. Right? That is why a ray of light moving from a rarer medium to a denser medium always bends towards the normal. Whereas a ray of light moving from a denser medium to a rarer medium moves away from the normal. We can prove this in a similar manner. Let us suppose here we have medium 1 and medium 2. This is denser and this is rarer. This is my normal. This is my incident ray. This is the angle of incidence. Now in this case what will happen? Sin I by sin R here also is equal to n to 1. Now in this case, since 2 is rarer medium, that means n to 1 will be less than 1. That is n to, this implies sin I by sin R is less than 1. This implies I is less than 1. That means angle of incidence is less than angle of refraction. So that is possible only when this ray goes away from the normal. In that case, angle R will be greater than angle I. Right? So here in this case, the refracted ray goes away from the normal after refraction. So that means now you are getting the idea that when a ray of light enters from one medium to another medium, due to the difference in refractive index, it either bends towards the normal or it bends away from the normal. And this bending of light is known as a refraction of light. Now let us look at the phenomenon of refraction through a glass slab. What happens when a ray of light passes through a glass slab? That is, it first enters from air to glass slab, then again it moves from glass to air. That means there are two transitions. First there is a change in medium when it enters from air to glass. Again there is a change in medium when it moves from glass to air. Now what happens in this case? Let me name this medium as medium 1, this is medium 2, and then again this is medium 3. These are the three different mediums through which the ray of light passes. What happens when this incident ray strike this medium between 1 and 2? What is the normal to the medium? This is my normal to the surface, right? So this is my angle of incidence I1, and this is the refraction because it enters from a rarer medium to a denser medium. Because which is a denser medium? Because the refractive index of air is 1 and the refractive index of glass is greater than 1. So glass is a denser medium than air, right? So it is entering from a rarer medium to a denser medium, so it bends towards the normal, and then again it moves straight. Again it reaches at this point when it enters from a denser medium to a rarer medium. So what it does, it goes away from the normal. So in this case the angle of incidence is I2 and the angle of refraction is R2. So what do you see? This was your incident ray which entered the glass slab, and this was the ray which emerged out from the glass slab. So this ray is known as the incident ray because it was incident on the glass slab. This ray is known as the refracted ray, and this ray which comes out of the glass slab is known as the emergent ray. Now what do you see? You observe one interesting thing, that if you assume that there had been no glass slab, had there been no glass slab, your incident ray would have moved straight like this. Now, if you see, if there would have been no glass slab and if somebody would have observed, he would have observed this incident ray, right? But now if you place a glass slab, the ray which is coming out is this emergent ray, and this emergent ray will be visible to somebody who is observing it. So that means somebody who is observing an object is not observing the real position of that object, because there is a lateral shift involved between the actual incident ray and the emergent ray, and the emergent ray is the one which reaches the eye of the observer, and as a result, let us suppose if this ray reaches the observer's eye, he will assume that the object or the incident ray is coming from some point here. So that means, but actually the incident ray's source is here. So the person will observe this point. So the person will think that the source of the incident ray is here. And this is the result. Why? Because of this change in medium, or because of the phenomenon of refraction, we often do not observe the actual position of the object. Now, in one of our previous slides, I gave you some examples of refraction, right? Those examples will you can understand or you can explain those examples on basis of this concept, right? So now, in this case, another important thing which we can discuss is refractive index of medium 2 with respect to medium 1 will be equal to 1 by refractive index of medium 1 with respect to medium 2. Similarly, refractive index of medium 3 with respect to medium 2 will be equal to 1 by refractive index of medium 2 with respect to medium 3. What would be the refractive index of medium 3 with respect to medium 1? Let us suppose in this case we have medium 1 and medium 3 as same. Let us suppose if we have some system where we have medium 1, medium 2 and medium 3, and they are all different medium. Let us suppose this is air, this is glass, and this is water. So in this case, this relation will hold true. Now what would be refractive index of 3 with respect to refractive index of 1? It would be 1 by refractive index of 1 with respect to 3. Now in such scenarios, I can also say that refractive index of 3 with respect to 1 is equal to refractive index of 3 with respect to 2 multiplied by refractive index of 2 with respect to 1. So this is another important relationship which relates the refractive indexes of 3 different media. Right? So I hope you understood the phenomenon of lateral shift. This phenomenon of lateral shift is extremely important in the phenomenon of refraction. So what is lateral shift? Lateral shift is the phenomenon in which the emergent ray shifts laterally from the actual incident ray, right? This is the phenomenon of lateral shift due to the phenomenon of refraction, right? So now let us discuss the same examples once again, that why did all these things happen. Now let us look at the first example. Why did the pencil dipped in water appear bent to you? That's because when you are observing the pencil, you are observing on the lines of emergent ray. So the source of the incident ray is something different, but you are observing something different that is along the lines of the incident ray, and that is why you are not observing the actual position. Instead, you are observing the apparent position of the pencil. Similarly, in this case also, why is that you are observing a different position of the fish? That's because the light ray coming out from this fish, it suffers a refraction as it comes out from this denser medium to rarer medium, that is, it is coming out from glass to air. As a result, it suffers refraction. So when it reaches our eye, we observe the emergent ray and we try to see the object along the lines of the emergent ray. So we do not see the actual position, instead we see an apparent position of the object. Now if you consider the example of rainbow. In a rainbow also same thing happens. However, understanding rainbow is little it's not that complex, but at least there are a few more details that need to be explained. So we will take up the example of rainbow in our next lesson when we talk about the natural phenomenon or the atmospheric refraction, because for this we have a separate topic called atmospheric refraction, where we will see how refraction takes place in atmosphere. So rainbow is one such example. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.